Video, I'm going to walk you through the intelligent system that generates websites using RAG and LLM. I call it the AI website builder. Some of the components of this system, we're using a RAG system, we're using the BGE embedding models. The system will consume a PDF and then will persist those vectors in a vector database. In this case, we're using Face from Meta. For the LLM, we're using DeepSeek version 3, and we're using the Together AI hosting or cloud provider. We also added observability. We're using Langsmith. I'm going to show you that in a minute. We have our front end as well. We're using React and Next.js. We are using also Tailwind CSS. I'm going to walk you through the flow and how it works. So first we have our front end with React, Next.js. We also have our backend with Python and Fast API for our endpoints. We also have a couple of cloud providers. We have Langsmith and we have Together AI. We also have a database in the local file system, which is Face, and this is to store the vectors. So how it works, so when you first launch the application, it will consume the PDF that you have in the, I think it's called data folder. So it will load the PDF and then call the cloud. I'm just gonna make this the Together API cloud, and it will use the BGE embedding model for every chunk. So basically the PDF will create chunks, and every chunk will be sent to the cloud, to the API. The API will return a vector, and it will get persisted into the database. I'm just gonna make this back to the database. Actually, it's getting processed first by the application, and then the application will persist it in the database. That's the first step. The second step is when the user makes a query. And remember, this system generates a website. So the user will send a natural language prompt. For example, create a website or create a shopping cart with my data. So the system will use the PDF as the data to create a website. So for example, if the user says create a shopping cart using my electronics products, and it will create a website, an HTML website with JavaScript, CSS, and use all those products that are in the PDF, that are in this case in the electronic category. So let's say the user makes that prompt. The front end will call the back end through a RESTful API that we define with Fast API. And then the back end, the first thing that it's going to do is going to make a similarity search to the database, to the vector database, using that prompt. The vector database will return some chunks that will be in approximation of the prompt. The backend will generate an extra things in the prompt, such as the user prompt, whatever we return from the database, from RAG, and then some other system prompts, instructing the LLM to generate a website based on that information. Then we will call the API, in this case the LLM, which is DeepSeek, and DeepSeek will return HTML content. We return that HTML content back to the front end, and in this case will be HTML tags in a combination with some CSS, JavaScript, and things like that. we will grab this HTML content and then we will display it in an iframe for the user. So that's basically the flow. Now let's jump into the application. I have here my front end, which I'm running it like this, and then I have my back end, which I will run it this way. Oh, by the way, I'm using this PDF. So if you go to the backend and then data, you have this retail manual PDF. It's just fake data. If you see here, it has some catalog, some products, some sections for frequently asked questions, information about the store, employee guidelines, store procedures, promotions, etc. So if we go here to the website, we refresh it. I'm just gonna remove this, which is for development purposes. And then we can start chatting with the bot, right? We have this UI that allows you to talk to the LLM, use natural language, user prompts, and we will see the website being generated on the right side. So for that, I can say create a website for a shopping cart, or actually I'm gonna say create a shopping cart. Create a shopping cart with only electronic products. The shopping cart should be functional. It should include buttons. Use cards to display every product. And let's see. By nature, the LLM is non-deterministic. So if you use this prompt multiple times, the result will be different every time. But we'll see. So we see now the LLM returning some tokens. In this case, the tokens are pure HTML. And then we are displaying it as they come. You see that it's flashing, and that's because the HTML is not well formed until you see the end tag, in this case the end HTML. So this is basically what the LLM generated, right? Pure HTML, some CSS, and things like that. So we see here that it returns some items, and if we can see, as we instructed, well, it's kind of working. It was kind of working. I want to refresh it. It's kind of working. You see here, it's not 100% reliable, but as you can see, you have the shopping cart here. We need to see if that data, those products, are in our shopping cart, actually in our PDF. So we have noise cancelling, so it should be here, and the price is $39, and we see it's an electronic. So we see here price $39, USB cable, portable power bank is here, and the price $22. And the cool thing about this, I can just improve my website. I can say change the background to dark blue maybe. So the LLM has knowledge of the previous conversations. In this case, it will render the same HTML that it was before, but only making the changes to what I just mentioned. In this case, just changing the background to blue. And we'll see if this time will work, and we can add more items to the cart. No, it's not working as we expected, but that's fine. It's a prototype. Now, another thing what we can do, for example, and by the way, with this clear all, we're making another API call to the backend, and it will clear the context and the whole history, and then set everything as default. So for example, I can say create a website that is informative to the employees about, and let's see the document here, and let's see what we want to display. We want to display, let's see, employee guidelines and store procedures. Yeah, and I'm gonna say use a nice theme using red and white colors. So right now, as I mentioned, the system is gathering information from the PDF using RAG techniques. It will find it will do a similarity search, and it will probably find this section and return all this section. And yeah, it's generating the website with the colors we ask. Just give it a second. It's almost done. Okay, so let's say you have this system in your company and you want someone in the company to create a website for the internal employees just to show them the guidelines and procedures, and you can, as you can see, they can create this website in just few seconds or maybe a minute also. Now let's compare the content of this website. We have the opening, checklist, closing, procedures. If we open our PDF document, we see arrive 8:45 a.m., which is here. Turn on lights, verify float cache, and everything is in here. Unlock entrance at 9 a.m., which is here, and then the closing is the same, 8:30 p.m. and all that. And then we have over here customer interaction, always greet customers within 5 seconds of entering the store. So if we look at the document here, it says here always greet customers. So yeah, so the content of the website is matching our PDF. We also have promotions. If you see the PDF here, we have promotions. We have July, August. On July, 50% off. So you see here, right? Very nice. Some frequently asked questions, and the LLM put it in this way. Very nice. Okay, so what's next? We want to add observability, and we have LangChain for that. So I already set up here, our code is instrumented to capture all these metrics. So here, for example, I have, let's see the last two queries, and you see here it took 42 seconds. We can analyze that call, and we have system prompt, and then we have the human prompt. And I just want to show you something here. This piece. Create a website that is informative to the employees about guidelines and store procedures. Use nice theme using red and white colors. That's exactly what we use in our previous prompt. So this is the call that we made. So let's analyze what we have over here. So we have a system prompt. This system prompt is always append to every call we do to the LLM. And it says only use HTML, CSS, and JavaScript. For your response, do not include any other text. And then we are instructing the LLM to use Tailwind, CSS, use icons. We are providing the tags to do that, fonts, animations, all this stuff. And then here, as you notice here, this is the user prompt. So what is all this above? So basically all this above, it's coming from the RAG. all this similarity search that was made before calling the LLM. So it says here, from the retail manual PDF, this is the similarity search. So as you can see, this is what we wanted, and things are coming above and things are coming below because it is a similarity search. It's just texting that are around that is similar. And then we have more here, and I'm going to show you we have other here. So we have basically three. We have here the relevance, and another one here, and another one here. I'm going to show you how that was appended, and we have another function here, and as you can see, both were made almost at the same time. The similarity search, it was executed first. So we can see it created a similarity search based on the user prompt, and we returned 3 results, actually 4 results. And we can set that in the code. It's an environment, it's a global variable. We want to, how many chunks do we want to return? Depending on the size of your PDF, if we only set to 1, we will not get the other information, right? If we set to more, we may get unnecessary information. So there is also a trade-off there. Now, here is the response, the output, the response of the LLM. So it's adding here the HTML that we just saw getting rendered, and it responds with some other text. We don't see it in the UI because I'm parsing it, only the HTML portion. Even though we instructed the LLM to not include anything else, it's still doing it. It's just the way they work. They are non-deterministic. So you need to work to make some things, you need to make work around in certain things. So that's the way I did it. I parsing until I find an HTML tag, or actually this tag first, and then getting everything all the way down until we get the closing tag from the HTML. This one over here. Now, with Langsmith, you can also create your own evaluations. You want to see how your model is behaving. And by the way, for this call, we can see here how many tokens were generated. In this case, 5,000. So if you go here to tracing projects, I have here called evaluators. And I have the evaluators here. And a better way to see it is going back here to the chat call. We can hear LLM calls. All of these are LLMs calls. If you go back to the other one and you see the similarity search, that is not an LLM call, it's calling the database. Now, I want to make something clear. This user query or user prompt needs to be vectorized as well. So we need to call the API, in this case the BGA embedding model, and then get the vector representation of this system prompt. Then we can make a similarity search. So yes, we are in a way making a call to another model, but this is making the call to the LLM. So when you go here and then you go feedback, and by the way, I set up these evaluators. They don't come by default. You need to go back here and then click rules, and then you can add a rule. I created 3 rules. One is conciseness. I'm making sure that the response is concise. Here I'm making sure the code, in this case the HTML, is correct. And here I'm checking if the model is making any hallucinations. And I'm using an LLM as a judge. In this case, I'm using OpenAI O1 as a judge. I can show you here a little bit of that. So here, you see there is a prompt. You are an expert data labeler, evaluating a model for hallucinations. You need to do this. The HTML tags are properly closed, blah blah, all that. And then if you see here, I'm sending the input, which is the user input, and then the LLM output. You see here the input, the output, and this other LLM running on OpenAI here. You can see here is running this and then analyzing it, and then down here it will return true if the output contains hallucinations, otherwise will return false or 0 or 1. The conciseness, I believe, is returning a value from 0 to 10. So here we're instructing the LLM as a judge to do the following: avoid any restatements, include only necessary tags, do not include summary lead, blah 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 blah. So yes, we are running these 3 rules per call. Every call will get those 3 rules. So we can see here the analyzer score as 1. We can see why. Yeah, so it's saying here the HTML solution provided fully adheres to the problem specifications and only use valid blah blah blah. Then overall this is complete, correct, efficient, and well. Oh, actually, this runner returns 0 or 1. It's not 1 out of 10. It's true. In this case, true. It's the code checker. It's true or false. In this case, true. Good check. And then if we go back and we check the conciseness, in this case, the score as 2, kind of low. And it will tell you why. The code itself appears self-contained and exhaustive from the code perspective is acceptable, but the graphing commentary heavily reduces conciseness. This is what I was telling you. I instructed the LLM to only return HTML, but it returned some text above and below the HTML. We don't want that, so that's the reason it's setting it to 2. So yeah, that's basically adding some evaluators. And then for the last one, hallucination, it returned false. 0 is false. You can see here, you can read all the comments. The color theme is red and white because that's how we instructed it, and yeah, he's saying yeah, that's correct. And at the end, the score should be false for hallucinations, no hallucinations detected. So that's pretty much what we have. Thank you so much.